Thank you, everybody, for coming, and thanks to Rise for a fantastic event space. Tonight, my goal is not just to tell you about blockchain and the decentralized world. Tonight, my goal is to change your life. And if I don't change your life, you can have your money back. Okay? So, I'm going to show you about blockchain, and I'm going to be covering these areas. And I kind of want to make it start with a quick story about this thing that we're flying around the sun on at a speed of about 18 miles per second with about 7.1 billion passengers running about an $81 trillion economy and about $800 trillion of above-ground assets. These are difficult numbers to grasp, but this is kind of the order of magnitude I want to talk about tonight. I think that we're at the end of about 30 years of digitization. 30 years we've been digitizing everything, and I think that has plateaued, and we've come to a fork in the road. And the one path, we can continue trying to optimize what we've got, or we can try something entirely new. And that new concept is decentralization. Decentralization, I think, will be one of the defining concepts for the 21st century. And a big part of that will be blockchain. So let me contrast with centralization. In the centralized world, we have governments and organizations that give us the ability to do commerce every day. We get these things. Here's some. And we get credit cards, debit cards, residency permits, insurance cards, driver's licenses. All this stuff comes from central authorities. And what else? This stuff too, right? Comes from central organizations with big bureaucracies. Okay, and that's the centralized world. And we're used to living in it. Things have been centralized for so long now that it's hard to see anything else. This is what it looks like. This is our everyday experience. This is the user experience of the centralized world. And this is what it looks like behind the scenes. In every city around the world, the largest buildings are banks and insurance companies, filled with people, floors and floors of people, pretty much pitchforking data around, the same routine most every day, over and over and over, except when they make mistakes. And what is behind their screens are data centers. Huge operations that cost tens of millions of dollars to spin up. This one is Facebook right here. How many of the Fortune 500 data centers have been hacked? How many of the Fortune 500 largest companies in the world have been hacked successfully? All of them, 100%. Almost all of the top 2,000 companies in the world have been successfully hacked. Why? That's where the data is. A little bit of failure goes a long way. When the data is concentrated, oh, I see my problem. There we go. We lose about $400 or $500 billion worth of cash and data every year from central servers. We spend about $80 billion a year on cybersecurity to try to prevent that $400 to $500 billion theft, which continues to happen. We got about $60 billion in insurance fraud. About 1 trillion records are stolen every year, personal records, about 100 million cases of identity theft every year. The Target hack released, in the Target hack, the hackers stole 70 million people's personal data from one hack. That's names, addresses, credit card numbers, social security numbers from one single hack. And worldwide, we got about $1 trillion in tax evasion. So central servers, central authorities are doing okay, but maybe we can do better. And that's the decentralized world. By the way, how many people here know what a hash function is? Okay, you're in the wrong place. And anybody mostly confused about blockchain, Bitcoin, Ethereum, don't really know what it all is, you're in the right place. Awesome. I see 6 people here. Decentralization is kind of like email, right? When you send email to somebody, it doesn't go through a central hub. It just goes through a mesh network of nodes, and if any one of them is down, it reroutes and finds its way to the destination. You can take down half the nodes in the network and email will still be fine. And so the decentralized world looks about the same. The interface is roughly the same, but what's behind it is a mesh network of anybody who wants to put a computer on the network can and make a little bit of money, and it's completely ad hoc. It grows and shrinks. And right now, in the Bitcoin network, running the Bitcoin currency, there are about, 5,000 computers actively making sure that the network is secure and computing everything the same, so that if 4,900 of these computers are wiped out, the remaining 10, or 100, the remaining few will have the same information and can just reconstitute the network. So it's very redundant and resilient, and has no center and no central control. And that's the world of blockchain. This is a slide you're going to see a few times. It's in the document I mentioned. You don't have to take any notes. Don't have to put up the pictures, cameras. What can you do with a blockchain? You can store value. You can exchange that value. You can store permanent records, and you can execute programs to manipulate the value that you've stored on the chain. Okay? And that's what we're going to be seeing tonight. You'll see this slide a couple of times. This is kind of the central thing to remember. And we're going to learn the vocabulary. So here it is in a nutshell. You have a checking account, and you have to constantly reconcile your checking account with the bank's story of how much money you have. The bank always wins that argument, but you're always struggling to figure out how much money you have in your checking account. When you file your taxes, it's the same thing. You run through an exercise every year of figuring out what you owe. Then you tell them, the government tells you, and you reconcile, and then you net out the difference. The government always wins that argument. When you send $1 to somebody in a bank transfer, does that dollar transfer right then? Oh no, every bank has its own version of electronic dollars, and they send IOUs at that moment, and then they wait till the end of the day and they reconcile and net out. It's even worse in stocks. In stocks there are custodians, and so many chains of pairs of hands hold on to your stock from the time you press the buy button till you actually own your shares is 2 to 3 days. So we have replicated our paperwork flows with electronic paperwork flows. And a blockchain simply is a shared ledger. It's a shared ledger that everyone trusts to be accurate and permanent. A blockchain is a shared ledger that everyone trusts to be accurate and permanent. This is in the file you'll get when you go to my website. So an accurate and permanent ledger that people who even don't trust each other trust to be accurate. So that when you file so in this world, if we used the blockchain to file our taxes, the taxes would always be done. It would be automagic. If we used it to write checks, which is a silly idea anyway, but to exchange money or to send value, it just transfers. The value just transfers because it's all right there on one ledger. Right? This sounds like a small deal, right? Okay, well, that's some accounting stuff. But in fact, this one trick wipes out most of the people on most of the floors in most of those big buildings around the world. This is probably this one little trick of sharing a ledger, which you'll see several examples of tonight, probably wipes out $1 to $2 trillion worth of waste from our worldwide economy. $81 trillion. So it's a small thing, but it leads to huge change. So we're going to learn the vocabulary tonight, and these are the terms we're going to learn. And I'm not going to tell you, I'm going to show you. As long as I don't get any wacky messages, I should be able to show you the Bitcoin network. This is live. Whoa. Aha. I don't have a way to, I see, I'm in trouble. I see, now I have to stop sharing that. Oh. Okay, I can do this. Now do you see my screen? Yeah. Okay, that's good enough for now. This is the Bitcoin blockchain network of computers running transactions in real time on the Bitcoin network. And now I'm going to show you the Bitcoin blockchain itself, hoping a few people have never seen this. This is called a blockchain explorer. And these are the transactions coming through the Bitcoin blockchain right now. If you spend a minute here, you'll see some pretty big numbers. People are moving blockchain at a reasonable rate. It's about 6 or 7 a second in general. And every 10 minutes or so, someone turns these into a block and records it. And that block is right here. So here's the latest block right here. And a couple things we can see. First, we don't know what the next block is because this is the head block at the moment. We can see the previous block. There are 1,700 transactions moving about $560,000 worth of value. Small transaction fees compared to that. It's about 1% of 1%. Transaction fees. Send $1, send $1 million, same fee. Has that ever happened to you before with a bank? No. Right, it's just a number. So what does the transaction actually look like? So there's a little bit more. This is the block header. This tells you some other things about the block. And you can see we're almost at the dreaded block limit here. And the fees are here. And this is the reward for making the block. The node that makes the block gets a little reward. And here come the transactions. This is the chain right here. This is what's on the chain. So I want to make it clear. This is an address. It's called a public key. This is one transaction. It's from this address to these 3 addresses. Actually, I have no idea what StrongCoin is. Goes these amounts. I usually can find some bigger, more fun transactions. Here's one for $62,000. That's a good start. So from this address to this address goes 110, and to this address goes $62,000 worth of Bitcoin. There are 3 numbers in this ledger, and that's all there is. There are no accounts on the blockchain. There are no accounts on the blockchain. An 8-year-old kid can generate one of these addresses. I have one right here, just so you can see it. This is the public address you would share with anybody, no problem. In fact, if somebody would just whip out your phone and send, say 1 Bitcoin to this address, I'll be happy to get it. But of course, I would be able to retrieve it only using this address and move it somewhere else. For example, move it to another Bitcoin address, or to exchange it with someone on an exchange for say U.S. currency or something like. So this is a prime number, and to be able to move the money from this account, you'll have to guess this number. This is like having a combination in lock with 140 numbers on it. Okay, and these are pretty much random, so we don't store them in sequence. We're just generating this stuff on the fly. This is essentially called a wallet. You can send money here and move it away only if you have that key. That's the private key. So when you see the public Bitcoin blockchain, you will not see the private keys. You will just see the public keys. From this address to this address, this much, that's all that's there. There's no know your customer, no names, no addresses, nothing like that. All right, so then a couple of years ago, a young computer science student looked at the Bitcoin blockchain and all the different things people were doing to try to get more value out of it, and decided that he could make a new blockchain called Ethereum that would just be programmable, fully programmable. You could just write any code you wanted. And a lot of people got excited about that. They had a little crowd sale and raised $18 million and launched it about a year ago, a little more. And that's called Ethereum. Ethereum is also a blockchain. It's very similar. I'm going to show you a different view of the blockchain, of that. This is a different program that looks at that. I can't show you the transactions in real time because nobody's written that. Nobody's created that Explorer yet. But these are the blocks. And one of the things you see about the Ethereum blockchain is that this is not every 10 minutes. This is more like so many seconds, or one, on average, maybe 1 minute. So it's a faster blockchain. It has fewer transactions on it. And those transactions, so here's a block. How many? It's got one transaction. Here's 21, one that has 21 transactions. You can see the previous one and the next one that's just done by addressing, right? And here are 21 transactions, and here they are. Again, you know, from, and this has a nickname. These are addresses. Here's one. To another address, and this has 0 Ether. So here's one. This address to this address. Again, 0 Ether. This is with a contract. So this is probably putting a contract up, maybe, onto the blockchain. And these involve those contracts. And those contracts are code that can be included. So you have from, to, the amount. And this is in dollars here. The amount and, oh, sorry, this is in Ether. Sorry, here's the amount. And then some code. And the code can execute on the network, on every single machine in the network. I'm going to show you that now. I'll tell you about it in a minute. This is called a smart contract. So here's a small smart contract for registering yourself, your identity, and it has more to it. But you can see it looks like normal code. It's sitting there in the public domain on the blockchain. You could steal it and just modify it and make your own. It's essentially open source. It's public. Here's one for a flight delay contract. As I mentioned, I'm starting a new company. My partners have just 4 days ago put the first real live insurance smart contract on the Ethereum blockchain. The first insurance contract ever on a blockchain just happened this week. Last week. And this smart contract says, if you send, let's say, $10 to this address, and you include your flight number and the day of your flight, then if your flight is delayed and the information comes from the airline automatically, then it will automatically send you 10 times your money back. So you put $10 into that address, you'll get $100 back. And if your flight is canceled, you'll get 30 times your money back. So there's actually a calculation, but it's roughly 30 times your money. So you send $10, it's gone, your flight arrives on time, you never think about it again. But if your flight is canceled, 30 times, $300 will go back to your address, and that will be the end of it. There's no people here, there's no number to call, it's just some code that's sitting on the blockchain that executes exactly as it was told to do. And I'm not going to give you a tour of the code because I have no idea how all the code works. But here is, I'm going to show you this now because to do it later will cost this overhead of switching the projectors again. But this is a tool for helping lawyers design smart contracts that can't be done wrong. So all of these things fit into each other. So this ensures the grammar is valid so that you can write smart contracts without making mistakes. It's just a little visualization tool for people who don't normally code. Lawyers are going to have to code. Any lawyers here? All right, lawyers are going to have to learn to code. So this is just a way to get started learning to make smart contracts. And this one is for to sell something. There's one for the Tooth Fairy. These are just little examples, and it's a little teaching tool. Here is an insurance policy. By the way, it's a little more work right here, and so forth. So you can see you can add parameters. You can change the dates, the months, the amounts, and so forth. And then here's one for rock, paper, scissors. You can take this and modify it to suit, and this helps you learn to code. So now I'm going to go back to my presentation and try to unmirror displays. And have I done it? Yeah. So we've learned a bunch of these terms already. Ether is the native amount to the Ethereum blockchain, just as Bitcoin is the native amount, currency, to its blockchain. Some blockchains have their own currencies. Some use other currencies. For our insurance contract, you can send it either Ether or Bitcoin. It'll translate it into Ether. Now I want to try to dial in the smart contracts, and then I'm going to talk about distributed applications. So smart contracts. Let's just get a sense right now of what an electronic contract is. When you're shopping to rent a car, say, you're in the app. This is the app. It presents the content, and it might have a matching engine, registration, accounts, and so forth. But then when you click Pay Now, you are executing a contract, right? You're aware that when you're at Amazon, right, and you click, you're making a commitment, and that's technically a contract that has rights and obligations. And in case something goes wrong with this contract, you don't get your thing, something happens, the thing is defective, then you can read the fine print because the contract that is behind this button is a document that's written, and you can access that document and see what your potential options are, right? Because that written contract, which is usually in very small print, is the final word on what happens after you click that button. After you click that button, some software happens, some people happen, some deliveries happen, so forth, but that is essentially a contract. And now smart contracts are a little bit different. I'm going to read you the definition. A smart contract is software that runs on every computer in the Ethereum network. It is on-chain code. It's unambiguous. It can transfer asset ownership, and the results are recorded on the blockchain forever. It may be made up of subcontracts and have unknown dependencies. It could wait for a long time for other information to come in, like whether the flight was canceled or not, for example. So it can wait a long time. It cannot be stopped except according to predetermined conditions. It essentially runs forever unless it plans to kill itself. It will execute as written regardless of any legal frameworks. It's not magically compliant with anything. And that is leading to many gray areas and interesting legal issues because it's hard to know which jurisdictions apply and within jurisdictions which law applies. So we'll be keeping lawyers busy for a while with this. And then finally, they are networked code and not private. So groups are working on creating libraries of contract modules that will form an active smart infrastructure that eventually will tie into smart legislation and legal frameworks worldwide. There will be many such libraries that you'll be able to build on top of in a modular way. And finally, contracts that are both executable and human readable, as we saw with that little tool I showed you at EtherScripter, are called Ricardian contracts. So that's a lot, right? But do you get this general sense? It's on-chain code. It executes no matter what. It doesn't care about lawyers. And it's both human readable and machine executable. Okay? So when we talk about smart contracts, it helps for people to get the same definition so they're talking the same language. This is something we just saw the demonstration of. And now when you're about to sign a smart contract, you may want to know what's going to happen. You may want to have some idea that it's going to do what it says it's going to do, because that is going to execute for no matter what. You cannot turn these things off. So there will be contract validation. And there will probably be validation providers that you'll want to trust. There's a competition at the moment going on to see who can gain the trust of people so that their validation stamp of approval says that the contract will do what the contract promises to do. The last thing, you wouldn't want a contract that says, stay at a hotel or take a trip if it's only costs $8,000, and then you start it and then it just takes your $8,000 and says thank you. You want to make sure that it's executing its obligations. Now, decentralized apps. Remember, we have the app and we have the smart contract. So the application could be on your phone, could be on a website, will be something that helps put a wrapper around these smart contracts, and I'm going to show you several. This is called Everledger, and they're starting with diamond provenance, the information that goes along with diamonds from rough to cut. and you'll be able to see each individual diamond. You can already do this if you go to everledger.com on the blockchain with all its information, and when the ownership of that diamond transfers, that is noted in the blockchain. So this is a way of keeping track of the provenance of things. There's a triple entry accounting system, and you can imagine that this is not just imitating the old accounting systems. This accounting system would interface to other accounting systems to provide a central shared ledger so that when a sale is made, the books are done. There's really, essentially, the sale is the bookkeeping. The taxes can be paid right there. Everything happens right in real time instead of reconciling later. So two companies wouldn't have separate ledgers. They would use something like this to share the ledger. And this is being built right here in Brooklyn by Consensus, one of the fantastic companies in this space. And then this is for clearing. There's lots of clearing happening on the blockchain. This one is for securities. There will be more and more securities tied to tokens on the blockchain, which I'll explain in a second. This is a replacement for eBay that is peer-to-peer. So people want to sell things to each other. eBay makes about $18 million in profit a year. And this is just some smart contracts and a decentralized app that essentially replaces that. Not all the marketing and high-touch customer service, but it replaces essentially the mechanics of listing things and then getting a buyer and doing the swap so that when you receive the thing, the money transfers, and if for some reason you don't receive the thing, then that's in the smart contract. What happens? You have to look at how the smart contract deals with that. There is no underlying written contract that governs this transaction. Here's one for turning land ownership into tokens that are represented on the blockchain, and then when you sell that token to someone, the land ownership transfers. And you can imagine all the air rights, mineral rights, zoning, and all the other requirements can be built into the smart contract and into the token itself. This land registry stuff is happening in at least 3 countries, one of which is Sweden now. So the experiments are actually pretty interesting. And you can imagine at some point that much of this will replace land registry and title. Title insurance won't be necessary when we can keep it on a shared central ledger. Here's a cool one for running a company and making group decisions, so you don't necessarily need a board. You can just have people in the company all vote on matters that are important, and that vote gets recorded on the blockchain, and it can even allocate resources. So if you want to vote on the budget and certain kind of budget passes, then the money can actually transfer. This is TallySticks, which again is an ecosystem for sharing invoices. So once again, you're not sending invoices to anybody, you're sharing the information so that the invoice is also, the payment. Essentially, you're trying to shorten the distance in the paperwork, to as small as possible. This is also being developed by Consensus. This is Gnosis. It's a prediction market, so you can make bets on things, and the outcomes of those bets can be used to resolve smart contracts, for example, or smart contracts can also help resolve the outcomes of the bets. This is part of what we call Oracle services, which provides dedicated answers that smart contracts need to resolve themselves. For example, in the insurance example I gave you, we didn't need an Oracle because we could get the data right from the airline on whether your flight's canceled. That's easy. That's through an API. But more complicated things will require different kinds of consensus around what has happened and what the outcome is. There's more than one social network happening on the blockchain now. Some of them use points that turn into cash for voting up. You've probably heard of Steemit, that vote up posts that people make, and that's real cash using their tokens that are become more and more valuable in the market that people want. So tokens are going to be a big deal. and you'll be able to trade your tokens on a market called Lykke, which I'm involved with. They're just launching their coin offering today. And on the Lykke market, it's kind of a competitor to like the New York Stock Exchange and the London Stock Exchange and all the stock exchanges around the world, all the foreign exchange and all the money exchanges. You'll be able to trade any token with anybody and get liquidity and try to get the best possible prices on this exchange. It's a smart exchange because if you've heard about the hacks of Bitcoin and the kind of big disasters of Bitcoin in the last couple of years, it's exchanges that aggregate a lot of value. And I can tell you right now that any exchange that aggregates the private keys of its customers will be hacked. So we've got some big exchanges out there, Coinbase, Kraken, Poloniex, right? These are big exchanges with lots of money. The bigger they get, the bigger target they are for hackers. So by aggregating value, they make it more likely that they'll be hacked. This particular exchange makes the match using a central server, but the value exchanges from wallet to wallet, so it's P2P exchange. So all of the value on this exchange, no matter how big it gets, is going to be distributed among all the different participants, so there's no value on the exchange to hack. And that is the future of exchanges. So there'll be many kinds of tokens. A good example is a ticket. A ticket will be smart. It will be on your phone. It will be a smart contract, and it will have provisions for what happens if the event rains or the performer can't come, or it will make sure that things don't duplicate, and when you use it, the token will be returned back. But it can also have rules, for example, that you can't sell it for more than it's worth, or it can have various discount codes, and there will be more and more programmability of things like tickets or voting mechanisms for different kinds of voting schemes. Or for this is a token. This is a token, right? That'll just be here, and it'll be in a way that no central server will be vulnerable. You'll just be able to use that through an exchange or with the kind of token you need to get through your day. And these tokens, there will be many, many thousands, tens of thousands of new kinds of cryptographic tokens. So get used to it. You're going to have your wallet right here, which will have many, many private keys. So key management is going to be a big deal. Is this going too fast for anybody? Should be. It's a lot, right? Yeah, that's fine. There's plenty at decentralization.com, and I'm just trying to give you an overview, so don't think you have to get it all. Here's a private blockchain. Private blockchains, there are a bunch of these now, could work for a consortium, a hospital group, for example, that deals with all its suppliers. Imagine, back to tokens again, imagine BMW does business in, let's say, 70 countries with suppliers and customers and so forth. What if they just issued their own BMW coin and everybody used the same coin? Now, that's an ecosystem where they can trade and it's friction-free, right? Think how much multinational companies pay for foreign exchange services right now, going in and out of the same currency over and over again, when they could just make their own token and use that to trade. That token may also increase in value if other people want to get into it. A little bit like airline miles. If enough people want those airline miles for other things, then the value will go up. Here's a cool example of a shared blockchain that is private. Most drug companies do clinical trials, and in most cases, they contract out with a company to do the clinical trials, and then they get the data back. And then they massage and cherry pick it and hand over the report to the regulators and say, this is what we found in the clinical trial. They rarely use open data. This is a project that's happening right now. It's just a screenshot, and it's also mostly happening in the UK. And in this, if you go look at this, there's a live website for this. You'll see the dots changing. And every time the dot lights up, that's a write to a shared ledger. So the people who are doing the experiments for the clinical trial for a drug are putting the results right onto a shared ledger that the drug company can see, but also the regulators can see and the watchdogs can see. So now when the drug company comes with its claim of efficacy, all the data, the raw data is sitting there on the chain, and everyone trusts that chain to be accurate. So you have to be able to back up that claim with all the data, not just with a subset of the data. And the watchdogs will be able to see if you've done a good job or not. This is a really important use case where people generally don't trust each other, and the reconciliation later is problematic, right? This is how this all got started, trading drugs, trading illicit things. It's very difficult to trust other people to make the trade, and that's true in many areas. So we will see plenty of private blockchains. We will see most lawyers learning to code. The reason is that contracts will become executable. You'll spend time writing your contract, then you'll debug it, then you'll run it on a test network for a little while, and then eventually you'll execute it. And you'll execute it along with regulations and laws that will also be code. And so it will all come together into a kind of ecosystem of not just digital, because a lot of it is digital already, of interactive, interoperable code that is executing and checking. Example, taxes. Every time you sell something, if we could be smart enough to switch to to not an income tax but a federal sales tax, a consumption tax, then every time you buy something, the tax would just automatically be paid, and it wouldn't just be rung up or put into a ledger. It would actually be paid every single time right to the government on every single transaction. The smart legislation and regulation will interact with the smart contracts to make that happen automagically. You can see a lot of lawyers will be out of business, but you'll have to learn to code, and you'll have to learn to start building these layered systems of libraries of code that all start working to build systems that work, for example, for cross-border trade. So you can imagine when you see a supply chain from a factory in China across, a landing in a port in California and being delivered on a truck to New York, you will see the data go all the way across, and it will be recorded on a blockchain instead of handed off from one system to another. And a token, does anybody have a product? Well, we don't have any good a token that can go across systems is called a rail. It's just the terminology. A rail is a token that goes across systems. So the UPC, the product code that I don't have an example of, it's a barcode on all your products. That's a rail. That can be used for distribution, warehousing, and then checkout, and then finally reordering and so forth, all the ordering systems. So that's a rail. You can imagine a refugee rail that helps give people identity and moves them through processing in whatever countries they land at, and then toward final settlement, right? So these rails and tokens will be very important as this decentralized economy emerges. So to sum all this up, the centralized model, we start with business logic and data that we've had for a long time, and we add security, and it's not working so well. The more value we have here, the more that gets pierced. In the decentralized model, we're starting with security because you can't hack those individual addresses. That's numerically impossible. And we're adding business logic in the form of code, on-chain code. We're working on data and standards for interchanging, so we get rails. Identity is a big project right now, and we're really opening the floodgates of identity after it's been stuck for so long in digital land. Now that we're really getting to interoperability, we're having good conversations about fixing identity and privacy and know your customer and all this stuff that the regulators want to see. Again, we are using the blockchain to store value, exchange value, permanent records, and then to execute programs that work with all those three things. Okay, where is this going to be used? Well, pretty much everywhere. Pretty much everywhere. Let's just think of media. In media, let me give you a wacky idea. You make a new song, an artist records a song. I'll go over here and not bother those people anymore. An artist records a new song, and every single second of that new song is a token. So the song and the token has all of its rights and all of its pricing information and works with smart contracts so that when the artist puts that song file online and customers come and buy that and pay for it in a bundle or individually, whatever, then every minute or every second of that song has its own provenance. So that if someone gets a bunch of songs and mashes up, makes a mix-up from a number of songs and publishes that mix-up and that becomes popular and makes a bunch of money, the money transfers automatically back to the, maybe could be 60 artists who make up the snippets that are provided in that. And that's, so now you want more mashing up instead of wanting to try to avoid mash. Now it turns everything around, right? By using fine granularity of tokens, you get a much more flexible system that lets us change the way we do music. You'll notice that in this model, and you can do the same thing for writing, blogging, TV, all kinds of things, the publisher is left out. And so there's tremendous savings in the P2P model of publishing of media. I have many other examples. Driverless cars and drones and things will need not a central server controlling them. That will never scale, right? We're already hitting the limits of central servers scaling, not meeting most of our needs, although they do in some cases. But for things that are autonomous, like driverless cars or drones, then we'll just use a mesh network. And the blockchain turns out to be really good for that. As we scale up the blockchain, we'll use little tiny tokens that represent a trip or usage of consumables and all these things. All that can be recorded on the blockchain and managed in a mesh network and smart contract way so that the cars can deal with the information themselves and work things out locally rather than having to go to the server. In fact, one of the largest software failures in history was the FAA, which spent about 10 years making a brand new generation of control software that was centrally controlling planes, and after about $2 billion threw it away and went to a new model called every plane gets all the information for the entire network replicated, and the planes have communication channels to just work out their own interactions. And that's more or less the way it's happening today, and that's more or less the way it will scale when millions of things are in the skies flying around. Every vehicle has a full copy of all information and is able to pass messages back and forth so they can stay out of each other's way. So this granularity combined with autonomy, or no central control, will give us mesh networks that will outperform almost everything we're doing today. Foreign aid. So most of the time when we want to help a country, say build roads or dams or dig wells or build schools, we have a contract. There's a bunch of contractors. We sign a contract. We send them the money. So-and-so gets to keep the money, and then he gives it out. And then at the end of the period, we find that 90% of it is kind of missing. And we're not sure, but we know that the roads didn't get built, and the dams didn't get built, and the wells didn't get dug, and the schools didn't get built. So now, using the blockchain, we can set up, and this is especially good for disaster services, everything ahead of time with smart contracts designating the exact addresses of everyone, say vendor, everyone who participates in this. And then when we see 100 yards of road built and we get the pictures and the validation of that, the smart contract automatically will then release that much money to the various vendors. When we see that the well is dug, when we see that the school is built, when we have a verified proof that the school has been built, the money goes not to middlemen, but exactly to the direct contractors who are responsible for the work. So if things have changed in the meantime, there are ways to make sure that the money only goes to the accounts or to the addresses of the people who actually do the work. This has a huge implication for development and for emergency aid, so that you don't decide as much, you set it all up as flexibly as you can ahead of time, but the smart contracts can move money quickly to where it's needed. There are a few challenges. They are not as big challenges as some people make out. Right now, security is very high on the blockchain. Hacking the blockchain is not impossible, but most of the hacks involve people leaking out their passwords. You can't actually hack the password by guessing it. It would take more than trillions of years to do that, much more than all the computing power on Earth. But if people store their private keys someplace that you can put malware on, then you find their private keys, then you can hack them. But it's essentially starting with very high security, data security. Speed right now is very slow. That is changing. Privacy right now, more or less non-existent. There are blockchain analytics software and teams that will forensically examine the blockchain to see who's doing what. And it's pretty remarkable what story they can put together if they really try through lots of, triangulating a lot of data. But that will change. And energy is relatively high, but I'm not worried about it. Right now we're spending something like $400 million a year on energy to run the Bitcoin blockchain. But we lose $400 or $500 billion a year to data centers, so a couple $100 million isn't a big deal, but that will change. Over the next 4 years, we're going to see a lot of changes in this infrastructure so that many of these challenges will give way to a new ecosystem that is very scalable and very fast and efficient. I'm not going to go through all of the implications. I'm going to just skip and go to one, and that's technological unemployment, in case anybody's been wondering about. So maybe for the next 5 years we have a lot to do, but after that, maybe we have scaled most of our work effort as well. So by 2020, we're expecting about 70 million new skilled workers, and about 90 million unskilled workers will not be needed. And these trend lines are going to continue. So a smart guy named Harold Jarsch says, identify what you can automate before the machines do. Get rid of the repetitive white-collar work and let software do that. Google has, almost 50,000 employees. How many people work in HR at Google? Around the world, all together. It's about 30. And they just pretty much maintain the software that runs HR. This is not recruiting, but this is all the HR function is done by software. And more, we're going to see software replacing the repetitive white-collar work that we're used to doing on so many of those floors of those tall buildings. So those tall buildings will be looking for new tenants in the next 5 to 10 years. Because the software, we know that robots are replacing jobs in manufacturing, right? You know that China peaked, the number of manufacturing jobs in China peaked in 1996. Number of manufacturing jobs in China have been going down for 20 years steadily because of automation. And now that is coming to the white-collar worker as well. Just last week, Wells Fargo fired a bunch of employees because they were setting up fake accounts, putting a little money out in them, and then sort of saying that they count, and that by doing millions of these fake accounts, they got bigger bonuses. right, to qualify for their quotas and their bonuses. They fired all these people on the same day. This was Thursday last week. How many people did Wells Fargo fire last week for setting up phony accounts to get increase in their bonuses? 5,300 people. 5,300 people fired on the same day for faking accounts. Do you think they're going to hire 5,000 more people to replace those people? No. Maybe they're going to be calling the IT department to figure out how we can replace them with smart contracts. Okay, so those jobs are not coming back. And the trust, David Birch says, banks, we're going to be able to handle the transactions and the security, not a problem. Banks will be the place where you manage your identity and your reputation. And that's going to be the new value of this decentralized economy. So this is going to be a serious rethink, I think. I hope you do too. This is our friend again. We can store value, exchange value, store permanent records, and execute programs. That's what a blockchain does today. As the decentralized world grows, we'll be finding more and more new ways of using information that will help build more mesh networks, more resilience, more anti-fragility into our systems that aren't reliant on any one person or small group. So the running of companies, for example, will be able to be done not by representatives and managers as much as by people voting and doing things that they, coordination among people rather than being managed and rather than having high-level decision-making. The same is true of countries, where I hope we'll have fewer representatives and more direct participation by citizens who will have more empowerment. So decentralization is empowering, right? It empowers individuals and takes away power from gatekeepers and bottlenecks. And that's what we're trying to do on this little spaceship flying around the planet at 18 miles a second. Two, I think, overarching themes of this next 30 years will be the rise of cities and the rise of decentralization. And in cities, we're going to have about twice as many people in cities in 2050 as we have today. So we'll have about 6 billion people in cities. That's going to be a huge game changer. And I think decentralization will come not just to our computing resources, but to the way we manage our institutions as well. So this is a journey we're on. We're just getting started. We are at the beginning of this fork in the road I mentioned. And the choice here is to continue on optimizing what we've built already, or to take a new path and try something that is a different model but has a better chance to scale. Now, let me ask you, what will you do about this after this talk? Will you say, oh, that was good talk. I can't wait till next week's Internet of Things talk, and then the virtual reality talk. That's going to be a good one too. Or will you do something else? What fork will you take? What is to be done? Should we fully commit to this new blockchain future? That doesn't make sense. Should we do nothing? Anybody here planning to do nothing? Of course, in reality, we'll see, right? Here's somebody who's planning to do nothing. That's fine. In reality, we'll see. Remember this in 2 weeks and ask yourself, are we really doing anything about this? What is to be done? What is to be done, I think, are two things. We have to learn, and we have to make some mistakes. That is what I think is to be done. We have to start learning and educating people about what's going on here, and we have to start trying things and build a little lab, or maybe with a partner company or whoever we can get. We need to build a little laboratory to try some things, so we're kind of building options for the future in case this really catches on. If it does, you don't want to be left behind. You want to at least have enough experience in the corporate DNA that you'll be able to expand on any little successes you may have found. We don't know what they are. This thing changes every day. Every week there's some new announcement about some new crazy addition to this ecosystem. But there's no excuse for not trying. Now is the time to put something together and see what you can learn. Now, I invite you to join me on this journey. It's an adventure into the unknown. It's scary. We could lose some money, but I think it's better to do it than to not do it. And I want to tell you why I do it every day, why I get up and I'm so excited about it. Because people aren't that happy at work in general. People are not that engaged at work. Many, many people are sitting in those floors and floors of office building, pitchforking that digital data around, and not really getting that much satisfaction out of it. Large corporations, large bureaucracies make decisions with a small number of people that everybody else has to execute. There isn't much autonomy, mastery, or purpose in most jobs today. And I think that smart contracts will actually give way to a much more creative economy and a way for us to fly this thing with fewer people, or maybe everybody working fewer hours. That might be nice, right? And the second reason I get up and do this every day is that we'll be able to bring the developing world into this new decentralized world in seconds, right? With all the stuff we're creating now, you'll just need a little feature phone or a smartphone from anywhere. All you need is connectivity. And we'll be wiping out middlemen who have been kleptocrats and, really skimming. We've got a $500 billion remittance industry just sending money home that skims off close to $50 billion of that. About $40 billion gets taken by the middleman, right? That $40 billion should go back to the communities, right? We shouldn't have to have big institutions telling people what they can do. It's going to create financial inclusion and a new sense of people in the developing world having access to all the same tools we have. And that's pretty exciting. That's the journey I invite you to join me on. I hope you will. Thank you.